Okay, good morning everyone. My name is Liam Rubleski. This is the Saturday session for Lecture 5 of the Schulich Ignite program. I'll get started in a couple minutes. We'll just give people a few minutes to connect to the stream and trickle in. Please do also make sure that you're connected to the Discord. Again, if you're not sure how to work with processing or Discord or this stream, you can feel free to go check out a video on this channel that explains that. That one is called Schulich Ignite Update. Also, as usual, if you have any questions during the session, please ask them on Discord if I don't need to see it. So if you have questions about the code or about the programs, please put those on Discord. If you have technical questions or if there's a question that you think everyone has, please ask that in the YouTube chat. I don't monitor the Discord chat during the stream. But I do monitor the YouTube chat because I need to have that window open anyway. And the other mentors in the Discord chat will be more than happy to help you, I'm quite sure. Okay, so we're going to get started on today's content. So what we're going to talk about today is a few different kinds of loops. So last week we started talking about for loops in the context of iterating over lists. And that's a really, really useful thing to have, and that's a really useful context in which to have loops. But there are other contexts in which we want to do the same thing over and over again, and so we're going to talk about a few of those today. We're also going to talk about getting input. So one of the things that you may have noticed so far is that doing stuff with our code is kind of difficult. And the reason for that is because we can't really do input right now. The only input we have is our mouse position, and it's really hard to make a game only using mouse position. They did it for a few years back in the 80s, but since then, more modern games use more inputs. So we're going to talk about those. And finally, we have a bunch of examples for you guys to work on. We will recommend that you are working in groups. Yeah. Is the audio working? Can someone post that in the chat, because my YouTube is telling me that it is not, but everything else is telling me that it should be. So I'm just going to wait for that to catch up. Audio is good. Fantastic. Thank you. Okay, so let's get started. So continuing on loops. So we're going to talk about this thing called range. So range stands for a list of numbers. So you remember last time what we were talking about is iterating over lists. So we would say for item in list, right? And that would iterate over the list, and it would have us run with item being every item in the list. Range gives us a list of numbers that go from 0 to 1 less than the number you give it. And there's a reason for that. You remember when we're dealing with lists that the first element is at index 0 because we have to skip over 0 items to get to it. The second element is at index 1 because we need to skip over 1 item to get to it. So if we have 9 items in an array, the indices for those items are going to be 0, 1, 2, 3, 4, 5, 6, 7, and 8, but not 9. Right? 9 would mean we have to skip over 9 items, and so that actually takes us past the end of our array. Sorry, our list. So that's why range does what it does. And then we can also use variables in there. We just wanted to show that just because sometimes people think that you can only use numbers in certain contexts. But you can definitely use variables here, and you can use stuff like length of list as well. So using range with loops is a really convenient thing if we want to repeat code, but we don't need any variables from a list, or we need variables from multiple lists. But here's our first example. So we want to just run this code 6 times. Right? We just want to print hi 6 times. So if we want to do that, that's fairly straightforward. And I'm also just going to switch over to processing so we can all see what's going on there. 1 second. Some brief. There we go. Excellent. So yeah, so we do def setup as usual, and if we say for I in range 6, print high. Right? We can see in our console that prints high 6 times. And so this code, because it didn't depend on a list, we can just say for I in range 6, and it'll just run that 6 times. Yeah, but another spot to use range for is if we need to use multiple lists. So some of you, I think, were already running into this last week. How do you deal with multiple lists? How do you iterate over those in such a way that you can access both of them at the same index at the same time? And there's a bunch of ways to do that that are more complicated, but kind of the most simplest and the most straightforward is the following. We just use range and then we access them both at the same index, right? So you see here we have 4 balls and we have 4 sizes, and we want to just draw these balls at their various sizes, you know, in their particular, this is their X location, right? And so the problem with trying to do this without using range is that we can only iterate over one of these lists. We can only say for ball and balls or for size and sizes, and then we have no way to access the other variable. But by using range, we can access both of them just by using the index, right? Because 100 is at the same index as 20, 200 is at the same index as 30, and so on. And this would apply no matter how many items there were. So I'm just going to, again, quickly switch over to processing. So instead of for I in range 6, we'll do for I in range 4. And I guess I will actually need those variables, so I'm just going to go up a couple lines and put in those variables. So ball equals 100, 200, 300, 400, and sizes equals 20, 30, 40, 20. And we will also need to do a size for our sketch. So we will do size 500, 500 should work. And for I in range 4, we're going to draw a circle. Balls at I, 100, sizes at I. One thing I am going to just quickly do as an aside here is if you are having trouble installing processing on your computer, we have come up with a solution. It's not a perfect solution. It's posted on the Discord, and you can ask Richard about it. I'm sure he'll be happy to help you. Sorry, Richard, for just pushing that on you all impromptu. But that's an online solution that'll get you processing 2, we think. It doesn't have circle, but it does have ellipse. It has a bunch of the functionality. So until we run into actual problems with that, we're going to use that as our interim solution for people having trouble with processing. Okay, that aside, let me show you now the results of this sketch. And again, just need to do a quick thing there. Well, that's very stretched. So that's very stretched on my screen. Give me a moment. Oops. Well, it's very stretched, but on my screen, it's drawing 4 circles. My apologies for that. I will fix that for the next sketch. That one, as kind of just a demo, I don't really think it's super important that that be very accurate. Anyway, returning to the presentation, how do we use, how can you use this? So if you recall, we had last time a dartboard. So that we did that by iterating over a list of sizes and just drawing circles at decreasing sizes in the same location. How could you color it? And that was the same kind of problem that we were seeing just now with we want to have 2 arrays, one of which corresponds to colors and one of which corresponds to sizes. So here you can see some code on screen that does both of those. So we have an array of sizes and we have an array of colors. One thing to note, we haven't really gone over it, but I've seen a bunch of people using it just because it's fairly well documented in the processing documentation, is that we have this function color, which just takes in the RGB values and returns a color. So we can have a list of colors here instead of having a list of red values and then a list of green values and a list of blue values. But that would also be a totally viable way to actually do this. It's just that it's a little bit less convenient than having the whole color wrapper. And then we iterate over range 8. So we say for I in range 8, because there are 8 items in each of these lists. We tell processing to draw in whatever color is associated, and then we draw the appropriate circle. So we draw the 225 radius circle first, then 200, all the way going down to 50. So I will also just pull this up as a quick example. And again, let me switch over to processing. So we'll do size. This one will be 300, 300. Again, I need to add these 2 lines just to work with my streaming setup. You don't need these, but this is why the last one looked super stretched, is because I didn't set these bits up correctly. So in the interest of having things represented properly, I am going to just quickly put these in. Okay, now we're going to do R equals color 255 00, G equals color 0 255 0, B equals color 0 0 255. Right, and so that corresponds to just red, green, and blue. Then we have sizes, and that is going to be, I'm going to make them actually just slightly smaller. 200, 175, 150, 125, 100, 75, 50, 25. And we'll have our colors. One thing you may have noticed is all of our iterating variables are, I've always used I. That's programming convention. I'd love to tell you why that particular one came about. The best I have is it possibly came from math. Mathematicians use the variable I a lot for that. Or it also might have come from the word iterator. So the iterating variable or index. There's a bunch of words it could have been and a bunch of things it could be. But the convention is just to use I for your range. So like if all you're doing is iterating over a range of numbers, the convention is to use I. So we do fill colors at I, and we do circle 150, 150, sizes at I. So again, what we're doing is telling processing to draw in the ith color that we specified in this list, and then draw a circle at the center of the screen that is the size, the ith size in this list, right? So if we run this, and I move this to a spot where it will be streamed without being unduly stretched. Hold on. I'm just going to set this to be that, and that will hopefully draw the thing without it being too stretched. Oh, technology. My apologies, everyone. Just give me a second to get this to start behaving. I'm actually just going to put this whole block in draw, just because it'll work better with my streaming setup. Again, you don't have to put it in draw, but for me, if I don't redraw them, then when I resize my window to be an appropriate size, they will be squished. Okay, there we go. And now I will switch over. So you can see our dartboard right up there in the top left corner. So again, this looks slightly different from the one in the slides just because I changed the sizes variable. Instead of using 225 at the front, I use 25 at the end. Doesn't really matter. But you can see that going from back to front, we have red, green, blue, which is exactly what I specified here. Red, green, blue, red, green, blue, red, green, right? So this looks exactly as we expect. And so this is one example of where you could use range that's really quite useful overall, because it lets you iterate over these two. And in fact, if you didn't know about color, one thing you might have done is instead of doing these arrays, this array colors, what you might have done was make an array R that was 255, 0, 0, 255, 0, 0, 255, 0, right? And then you could do a similar array that is for green. And what you would do is just do 0 instead of 255 as the first element, and remove 0 as your last element, right? And then so that would give us, sorry, we need to call this G now, right? And if we get rid of these up here, just so we don't have any confusion. So now if instead of making one array of all of the colors, we could make 4 arrays, one of which does our sizes, and 2 of which do our colors, right? So if we did 0, 0, 255, 0, 0, and I think that's it, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, yep. Right, and so here, instead of doing fill colors at I, we would do fill R at I, G at I, B at I. So you can see range lets us iterate over any number of lists that are all the same length. Okay. Now we're going to talk about while loops. So while loops work kind of similarly to if conditions, so if statements. So they check a condition. So this is a standard one. So while condition equals true, right? That checks to see if this condition is true. So as long as the Boolean statement following it is true, the code inside it will run over and over again. It's kind of they're the kind of truest form of loop. They just loop until you tell them to stop, right? For does things for each item. This just loops. So this is one way that we can use it. This is a very simple loop. So we set our variable I to 1. And again, we use I just by convention. So we say, well, I is not equal to 10. We want to print I and then increment I by 1. Right? So what will this do? Let's swap over to processing and have a look. So what we kind of expect this to do is print the numbers from 1 to 10, right? That's kind of what it looks like it should do, right? Because it's paying attention, we're iterating up to I equals 10, right? That's where we stop. And the only interesting thing really to note is what happens when I is equal to 10. So will it print 10 or not? And if we run this, we can see that it doesn't, right? It prints 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when I would be 10 and would be printed, it instead doesn't run and leaves the loop. Right? So that's something that's very important to keep track of, is what's your exit condition on your loops. Because it's very easy sometimes to make loops that look like they should exit on one condition, but they're actually exiting one early or one late. That's called an off by one error, and they're very common logical errors in programming. So how do we use them? So if we remove that last line, which I'm not going to do because I'm afraid it's going to crash my streaming setup, but you can feel free to do that at home. You will probably be fine. Processing will help you out in a moment. So if you do that, I'd like you all to just take a moment to think about what you would expect to happen. So while I is not equal to 10, print I, and then don't increment it. You don't do anything. What's going to happen is I continues being 1 over and over and over again ad infinitum, right? It just keeps being 1. and that line keeps running. So you're just going to get print 1, print 1, print 1, print 1, print 1, print 1 forever. So that sounds like a bad thing, but actually it's quite useful a lot of the time. We want to do something until something is true, or we just want to do something forever. So for example, in a game, you don't really want to just iterate over a particular list. You want to run your game until the user says they're done. You'll actually note that this behavior is kind of similar to how draw works. It just loops over and over again. So most of the time, this is not going to be something you're going to want to do in processing, but if you ever do anything else, then you might have some interesting things there. So we have a challenge question there at the bottom. So instead of removing I plus equals 1, what if we change that to something else, say I plus equals 2? What would happen then? And that one's actually quite interesting, and it relates to the question that's in there in the brackets. So I'll give you a minute to think about that, and then we will move on a little bit. Thank you, Richard. Okay, I hope you all have come up with your own answers. I think the idea was for this to be a challenge question along the lines of the sumo questions we've asked previously, but unfortunately for me, that was kind of a last-minute addition, so I wasn't super well prepared for that, so my apologies if that was the intention, but I am going to give you the answer to this now. Nope. No, I'm not. So those of you who have an answer, please do post that in Discord. Richard has apparently got something planned for that. So I am just going to move along here. Hopefully someone will have an answer in the Discord, and if not, you can feel free to ask your mentors later about why those behave the way that they do and why something like I is greater than 10 would be a better condition than I not equal to 10. Okay. So, moving straight along. I'm going to leave the camera off because I'm just barely occluding some stuff. So, how are while loops useful? So, like for loops, while loops are a great way to repeat code using multiple lists in exactly the same way. So we can take our same code from earlier that drew just some circles at various positions and change that to use while loop instead of the for loop. Which, you know, it sometimes just makes more sense conceptually. There's not a particular reason why a while loop would be preferable there, but I will show you what that looks like here, just so that we can all see what that would do. So you can see I have the exact same code that we had before for drawing all of our balls. So if instead of doing that with a for loop, we wanted to do that with a while loop, we would say I equals 0. Then we would say while I is less than 4, we want to draw whichever ball we're referring to, and then we want to increment I. We want to increase I by 1, just so that we're talking about the next item in the list. And again, this is going to work. This will show something, but in the interest of having it work well with my streaming setup, I'm just going to quickly add in some boilerplate code here. You don't need to worry about this. So Just give me a quick second. I'm working on making this segment of me making sure that things work with my streaming setup. I'm trying to shorten that. Unfortunately, it's running into technical challenges, so I will continue working on that, but for the moment, you just get to deal with me typing some stuff on occasion that doesn't quite match up with what you need. So my apologies to all of you for that. Okay, and if we switch back to our sketch, again, just 1 second. We can see again that we get the balls behaving in the circles behaving in exactly the same way that they did with the for loop, because it's got the same logic. We're iterating from I equals 0 to 4, not including 4. But this one kind of might make a bit more sense to you in some circumstances. So the recommended way is to use range for this particular kind of thing, but this works very well for iterating over multiple lists as well. Okay, we are now going to transition to our first exercise for you for today. So this is exercise 1. We want you to draw some squares. So we would like you to use a while loop to display 5 evenly spaced squares. So the x position will depend on the loop counter. And then, if you can, add another while loop to make squares with color. So again, the red, green, blue values, or the RGB values, will also depend on the loop counter. You can feel free to get fancier with it, but this is the exercise. Again, if you have any questions, please feel free to ask those on Discord. Just pop into an unused help channel, or if Richard has said any other way that you should do that instead. I am not the most up-to-date on that. Listen to Richard on that. But I'm going to turn off my camera and give you guys about 5 minutes to work on this. Okay, we had a couple people ask for a couple extra minutes, so we did that. We are now going to continue onward. We're not in a super huge rush. Again, keep in mind, this will all be posted as a video, so in the event that you didn't make it through this example or this exercise, you can continue working on that on your own time, pause the video, come back later, or what you can do is just literally come back to it tomorrow. This will all be available on YouTube. This is all posted on the Schulich Ignite channel, and on the Discord we're all happy to help you pretty much anytime during the week. So don't feel like you need to get these done right here and right now. But we are going to move on at this point. So what we have here is a slightly more comprehensive or complex, long week, slightly more complicated screensaver example. So you recall previously we had a screensaver where we had one ball bouncing around on the screen. Here you can see we have a few balls at varied positions, and they're all bouncing around, but whenever any one of them bounces, they all bounce. So let's transition over to processing and have a look at that. So again, we've got size 500, 500. That's fine. So we're going to start all of the balls in a position. So because these things are going to be changing over time, we need these to be globals. So we're going to make two global lists. So we're going to do a list x. So we'll do x is equal to, let's start this at, I don't know, we'll start one at 100, we'll start one at 150, we'll start another one at 125, and this one at 126. Then we'll do an array of y's. So we'll do y is, I'm approximately mimicking what's going on the screen, by the way. It's very approximate. I don't have the code for that because it's just sufficiently inconvenient for me to get it at this very moment. Okay, so what we're going to do is we're going to say y is, let's do 50 and 75, 75 and 150 and 200. Okay. And now, again, I actually need to do some things just to deal with the fact that I need to be able to resize my screen so it's streamable, but I will type this out first the way that it is on screen for the values I've set. So what we actually want is for the screen to be 1,000. So the size is 1,000, 1,000 instead of 100, 100. So we need to do global x, y, so draw is referring to our globals x and y. So for I in range 4, so iterate over all 4 elements of each of these arrays. We're going to say if x at I is greater than or equal to 975, or x at I is less than or equal to 25. So greater than or equal to 975 means that the ball is at the right side of the screen, and it's either just moved off the right side, or it's either off the right side or just touching the right side. Similarly, x less than or equal to 25 means that it is either off the left side of the screen or just touching the left side of the screen. So if either of those are true, then what we want to do is x vel times equals -1. So that means we also need a variable x vel, and that also needs to be a global. So we'll do x vel equals, I don't know, let's say it's 5. That seems large. We'll do 3. We're also going to need a y vel, and we'll also make that 3, I suppose. Okay, so x vel times equals -1. And we also need to put those in our global statement. Sorry for jumping around a bit there. And y vel. So what I did there, I added x vel and y vel, and I added those to the global statement right here. So if x is going off the right side of the screen or it's going off the left side of the screen, multiply by -1. Then we want to do the same thing for the top and bottom. So if y at I is greater than or equal to 975, that actually corresponds to the bottom. Remember, y increases from top to bottom. So it's 0 at the top and 1,000 at the bottom. Or y at I is less than or equal to 25. Then we want to do y vel times equals minus 1. And then we will say x at I plus equals x vel, y at I plus equals y vel. So that's updating our x position with our x velocity and updating our y position with our y velocity. And then we will draw a circle. I'm just shorthanding. X at I, y at I with a size of 50. So that's its diameter is 50. Right? And that gives us a radius of 25, which corresponds with these things here. So now I just quickly need to change this to width minus 25 and height minus 25. You don't need to do that. That's just so I can deal with the fact that my screen is resizing. And I'm also, yeah, that should work. Okay. Whoops, background. If you don't want an endless stream of balls, make sure to put in a background statement. So we'll do background 0. Okay, I'll run that again, and now I'll switch over to the sketch. Again, just 1 second for me to deal with the various things that I need to do. So there we go. So you can see my balls are, the balls that I've made here are a little bit more kind of, what's the word, compact than they were on the other one. I will also just quickly resize this to fit the stream, sorry. Well, that broke everything. My apologies for that, everyone. Believe it or not, streaming is apparently a complicated thing. Who would have guessed? Based on how many people have a career out of it. In any case, that's that example, more or less. Can we please go over how we made that sketch again? Yes. Yeah, I'll just go over it. So, sorry, Nadia, I didn't see that until just now because I had my sketch in front of the YouTube chat window. Sorry, I will fix that. Or I will not because YouTube chat is being irritating. So, my apologies, I will just need to keep that in mind for the rest of this session. Okay, so we will go over how I made that one again. So, starting from the top, this is all just some boilerplate. Again, size 1,000, 1,000, that's just some numbers. You don't need to worry about these two lines. Then we set up some global variables. So x and y correspond to the x and y positions of each of the balls that we are trying to draw. So in this case, we're trying to draw 4 balls. So we have 4 different x positions and 4 different y positions. I will also hide my camera so that I'm not occluding part of the sketch. Whoops, sorry. Wrong one. There we go. Okay. So these 2 lines, again, those are just the x and y positions of each of the balls. Then we set up some variables that keep track of the current x and y velocity. That tracks how fast is it moving in the x direction and how fast is it moving in the y direction. Inside of draw, we tell processing to go to a global scope to grab each of these variables, x, y, and xvel and yvel. We draw a background in black, that's 0. And then for I in range 4, so what we're doing here is we're iterating over the list 0, 1, 2, 3, 4, which, because we have 4 elements in each of these arrays, means that we're more or less iterating over these arrays. I'm going to just move these back to what they were and what they are on the slides, just because that will make explaining a little bit simpler. Okay, so our screen width is 1000, and this is 975. The reason for that is because we draw circles from their center. So if the center of the circle is greater than or equal to the total width of the screen minus the radius, that means that one side of the circle is touching the right side of the screen or is moving off of the right side of the screen. So what we want to do at that point is bounce the balls off the right side of the screen. And that corresponds to changing our direction back in the other way. Because xvel applies to all of these, that means all of our balls are going to change. Similarly, if the ball starts going off the left side of the screen, or it's touching the left side of the screen, then we want to reflect our velocity again. We want to start moving rightwards. And again, we will do that for all of the balls that are on screen. And so we do both of those by doing xvel times equals minus 1. So that's multiplying it by minus 1. That means if it was positive, i.e. it was moving right, it'll now be negative, so it's moving left. And vice versa, if it was moving left, it's now moving right. Then we want to say if it's touching the bottom side of the screen, or it's gone off the bottom side of the screen, or it's touching the top side of the screen, or it's gone off the top side of the screen, then we want to reflect its vertical motion. So that is just reflecting its vertical motion by, again, multiplying it by minus 1. Then we say our x position is going to be updated by adding to it our x velocity. So every frame, if it's moving right, we will add xvel. Right, in this case, that's 3. So if we're moving right, that'll increase by 3 every frame. If we're moving left, it'll decrease by 3 every frame. Similarly for y, if we're moving up, it'll decrease by 3 every frame. If we're moving down, it'll increase by 3 every frame. And the last thing we do is just draw the circle. Pardon me. So I hope that's a sufficient explanation for that one. Unfortunately, I can't spend too much more time on it. If you do have any other questions about that, please do ask those to the mentors in the Discord chat. But we are now going to move back to the presentation and continue onward. So I am now going to move just a little bit faster because that did take up a bit of time. I'm glad that helped, Nadia. Excellent to hear. So we're now going to talk about inputs, and this is where things really get interesting, because this is where we start to make programs that do things, depending on what the user does. So we've already actually talked about a couple of input variables. So we have talked about a couple, but we're going to talk about these two first. So these are status values, kind of. So mouse pressed is a Boolean variable that is true when either the left or the right mouse button is pressed, which kind of makes sense. That's just what its name is mouse pressed. So in a sketch, if you check the value of mouse pressed, that will always have true if the user is currently pressing either the left or the right mouse button, or both. And similarly, key pressed is a Boolean variable that will hold the value true if the current user is if the user is currently pressing any key on the keyboard. So I'm just going to do this sketch here, which is one of our examples. So we will switch over to processing again. See, one thing you'll notice, by and large, I'm actually just using the same sketch. Again, that's just for the sake of convenience. You can spin up a new sketch for every one of these. Okay, so I'm going to just set this to 960 by 540, and that should hopefully minimize my troubles with resizing things. I thought I had that figured out, so again, you all have my apologies that I'm still running into issues with that. So what we're going to need to do on this one is set up 3 global variables, R, G, and B. Those correspond to the color of our circle. We then, inside draw, need to say global R, G, B. We're going to draw a background. In this case, we're going to draw our background in white, just to match what's in the slides. And then what we're going to do is we're going to say if mouse pressed. So if the user is currently pressing the mouse, then what we want to do is increase our red value by 3, increase our green value by 10, and increase our blue value by 25. And then regardless of whether or not the mouse is pressed, we want to tell processing to draw with our current values of R, G, and B. And we want to draw a circle at this on the slides it says 500, 500, 500. I'm going to change that to width on 2, height on 2, and still 500. And that's just for, again, just for my convenience. You can use 500, 500, 500. Okay, so I am going to do that and switch us over to the sketch. And okay, so here we are, and you see when I press on it, it gets very blue very fast, and it gets greenish, and I'm just kind of tapping on my mouse button, so you see it stayed greenish for a really long time and then eventually turned white. And so what that corresponds to is the fact that in here we're incrementing blue way faster than we're incrementing green, or incrementing green well faster than we're incrementing red. And so because white is when all of red, green, and blue are 255, or in this case greater than 255, we get blue all the way up very quickly. It takes a bit longer for us to get to green, and it takes a very long time for us to get all of red up there. So we end up turning blue first, then greenish, and then finally, as we get more and more red in there, we turn to white. The color stuff is a little bit complicated, so don't worry if that didn't make too much sense. The important bit is that you recognize that it only changes when you're pressing the mouse. So you saw that it started at black, and then as I pressed the mouse, which you couldn't see unfortunately, I don't have a way to visualize that aside from the actual program visualizing it, is this: when the mouse was pressed, it incremented. When it didn't, the color stayed stable. Okay. So, mouse button. Mouse button tells us which mouse button the user is currently pressing. So, if mouse pressed is true, that means that the user is pressing either the left or the right mouse button, right? So mouse button tells us which one they're pressing. So mouse button is left, they're pressing left. Mouse button is right, and it's right. I think the behavior when they're pressing both is undefined. I think it might just be whichever one they started pressing more recently. Oh, excuse me, my apologies, everyone. So this example on screen changes the color that the circle is going to be drawn in depending on which button is being pressed. So again, we will just quickly pop over to processing and have a look at that one. So this time we don't need any global variables, so we can get rid of those. And then what we're going to do is also just get rid of all the stuff in here. So we're going to say background 255, and we're going to say if mouse pressed and mouse button is left, so that's left in all caps. That is important that it's in all caps. It's what's called a constant. So that's just something that the program knows about. It's a value left. It's kind of similar to true, and it's kind of similar to numbers too. It's just a constant that the program knows what that means and it can check against. So it's not a variable. Left is it's constant. If you have any questions about that, again, feel free to ask either me or your mentors. Okay, but if we're pressing the left mouse button, we'll say fill 0, 255, 0, and so that is going to correspond to green. We're going to say elif, mouse pressed and mouse button is right. We're going to fill 255, 0, 0. And you know what? We'll also do else fill 0, 0, 255. So our expected behavior for this is if I'm pressing my left mouse button, we'll get green. If we're if I'm pressing the right mouse button, we'll get red. If I'm not pressing either mouse button, then we will get blue. And we will say circle at mouse X, mouse Y, and with a diameter of 50. Again, if you're using the web client, you won't have access to circle, but you can do ellipse, mouse X, mouse Y, 50, 50. And that will work fine. Okay. And I will switch back over to the sketch again. And again, you will just need to bear with me for a second. Okay, there we go. So you can see currently I'm not pressing either mouse button, but now I'm pressing the left mouse button, and so we get green, exactly as expected. When I let go, it turns back to blue. And, oh, that's interesting. So when I press the right mouse button, we get red, also, as expected. If I then press the left mouse button, we get green. So this is me actually holding both, and it's reporting only the left mouse button. So yeah, you can see that the behavior when someone's pressing both mouse buttons is a little bit weird, but by and large it does behave as expected. So pressing left mouse button, we get green. Right mouse button, we get red. Neither, we get blue. Okay. So we now have an example for key pressed. So what we are now going to check is if the user is currently pressing any keys, right? And that's any key anywhere on the keyboard. So I'm just pretty much going to copy this one into processing. But the expected thing that we're going to see here is that if you press a key and we're not currently trying to draw a circle, then we want to try and draw a circle. Otherwise, if you pressed a key and we're not currently trying to draw a square, we want to start drawing a square, right? That's what those things on screen mean. And that'll make more sense in just a second. So what we're going to say is, whoops, I need to switch this over to processing. Again, I'm just using the same sketch, so I'm going to clear out draw, except for my background. So we need two globals. We need draw circle. We're going to set that one to true to start, and draw square, and we're going to set that one to false to start. We could have done it the other way around. I just picked circle to be true first. So if key pressed and not draw circle, right? So and not draw circle means and draw circle is not true, right? So and draw circle is false. Then what we want to do is set draw circle to true and draw square to false. Elif key pressed and not draw square, draw circle equals false, and draw square equals true. Then if we're trying to draw a circle, we'll draw a circle. So we'll do circle at 500, 500, 500. And otherwise, we'll do a square at 250, 250, 500. And I'm also just going to add in a fill statement just so that these draw in black. So we'll do fill 0. Okay. Whoops. I forgot my if statement on that second one. So if draw a square. There we go. And we'll space that out a bit just so it makes a bit more visual sense. So quickly going over it again, do our setup. We set up our global variables, and I need to make those global. Haha, I'm glad I went over it. Draw a circle and draw a square. Draw our background and set up our fill. Then if we've got a key pressed and we're not currently drawing a circle, we want to draw a circle. Otherwise, if we've got a key pressed and we're not currently drawing a square, we want to draw a square. So then if draw a circle, so if we're trying to draw a circle, then draw a circle. Otherwise, if we're trying to draw a square, draw a square. So again, I will just set us up, and that is off the bottom of my screen, I'm going to change a couple of these values real quick. Bear with me for just 1 second. We'll set those to 250, 250, 500 should still be fine. And we will set this to, I don't know, 100, 100, and 300. Sorry about that. Okay, that's a bit better. And again, just a quick second while I switch us over. And I'm actually just going to hide my video. Okay, so in here, it doesn't matter what I do on the mouse. I'm pressing the mouse buttons a lot here and nothing's happening. But if I press the spacebar, you can see that every frame that I have the spacebar pressed, it switches, whether I'm drawing a square or a circle. So if I press and hold, we get something that's a little bit seizure-inducing. So my apologies for that. But that's kind of the expected behavior. But it alternates between drawing a square and a circle, depending on how long I press that. Okay, I'm going to switch us back to the presentation again and continue onward. Again, we are running a bit late. You all have my apologies for that. We will try and get through this with not too much of your time taken up. Okay, key is another value, and so this is another input variable, and this is a string that represents which letter or number has been pressed. So if you're pressing an arrow key or shift or most of the other keys on the keyboard that aren't a letter or a number, those have a different variable that we'll come to in just a moment. But by and large, if you're pressing a key that corresponds to something you would expect to be printed on the screen, then it's going to be in key. So if you press the A key on your keyboard, then the variable key is going to have the value of the string A. And just a second there. Yeah, okay. So, a key example here. So, I am again going to switch us back over to processing. So, again, I'm just going to use the same thing again. In this case, we don't need any global variables, and I'm just going to clear out my draw function. So we're going to say text size 32. Now we're going to do text align center. For those of you who haven't seen it, text align is just text size, text align, and text are just functions used for doing text. So text size says how big it is. Text align says where should it draw the text in relation to the values I give it. And text itself, which I'm going to type in just a moment, is actually the function that draws the text. So we're going to say if key is not equal to the string space, which corresponds to the spacebar. So I'm just going to add a comment that says not spacebar. Then we're going to draw text key 500, 500. And again, that's going to cause me problems because of my particular setup. So I'm going to do width on 2 and height on 2. So again, you can just do 500, 500. Don't worry about that. Otherwise, so else, we're going to say text, and then we're just going to say the string space. Just to indicate that we pressed the space bar, and it's because if we just drew a space, then it would just look like a blank screen. So we're again going to do width on 2 and height, height on 2. And again, you can feel free to just use 500, 500 instead of width on 2 and height on 2. Another couple boilerplate things that I missed is we need background 0, and I think that actually should be it. So let me just run this sketch. Yeah, okay. Let me do that again and just switch us over to the sketch. Again, just give me a quick second. Okay, so you can see right in the center of my screen, there's this kind of empty square. That corresponds to no key has been pressed. But if I press D, so you can see as I press various keys, you'll actually also be able to see that I use a different keyboard because this is me pressing just the home row. So you can see as I press all of these keys, it just kind of works. You also see that it works for things like period and comma and all of the punctuation things that you would expect to work normally, right? All of those things work. And when I press the space bar, we get the string space. Okay, we have here our second challenge question. So again, if you have an answer to this, please do post that in the Discord chat, and Richard will award the first person who gets this correct to it will award the first person who gets this correct Ignite points, which he has a plan for, I'm sure. So the question is, how would you get this instead of printing 1 to print number 1, the pound sign followed by 1, #1. So if you have an answer to that, please plug that into the Discord chat. Again, as we are in a little bit of a hurry, I'm not going to spend too much time on that, but if you come up with an answer to that, please do post that in the Discord chat. First answer gets points. Whoops, that's the wrong thing. Hold on. Okay, there we go. So, coded. So, values that are not letters or numbers behave a little bit differently from values that aren't kind of things that you expect to print behave a little bit differently. So they use the value coded. So if you press something like Shift or Enter or any of the arrow keys, then key will be set to the value coded instead of any particular string. And that's with high probability, that's actually what it was set to when we started, is that it was set to coded. So when it's set to coded, you need to use a separate variable to check what value it actually has, which key was actually pressed. And the variable we use for that is the variable key code. Good, I'm not including anything. So what you want to do with key code is check if the key is coded, and if it is coded, then you check the key code to see which key was actually being pressed. So if you wanted to check if the up arrow was being pressed, you would check key equals coded, which checks to see that it's a coded key, i.e. it's not a letter or a number, and key code equals up. The reason you always want to do both of those checks is because if the person presses the up key, then key is set to coded and key code is set to up. If they then press A, key is set to A, but key code might not be changed. So if you don't check to see that key code is still coded, then you're going to think that they're still pressing A. And that's just kind of, it's a good way to be careful about things. Because keep in mind, programming is the art of being lazy carefully. So we have a coded and key codes example, and this one moves this ball around on screen depending on which of the arrow keys I'm pressing. So one more time, I'm going to switch us over to processing. And again, I'm just going to get rid of all my stuff in draw. So here we need two global variables, one for x and one for y. So we'll set x equal to width on 2 and y equal to height on 2. You can use any other value that fits on your screen. For me, that's width on 2 and height on 2 is just a common one. Okay, so inside def draw, we're going to say if key pressed. So we're checking to see, are there any keys pressed at all? Then we're going to check if the key that is currently pressed is coded. So that's not a letter or a number or a punctuation symbol, because all of those don't come out as coded. They come out as their appropriate string. Then we're going to check if key code is up. Then we're going to do y minus equals 5. Whoops, 5. Again, that corresponds to the fact that y increases from top to bottom. So if we want to move upwards, we need to decrease our y value. If key code is equal to down, then we're going to say y plus equals 5. if key code is left, then we're going to set x minus equals 5. And if key code equals right, x plus equals 5. Right? So that's all of our code to move our circle around depending on which of the arrow keys you're pressing. You could also do the same using WASD, but you would need to do the checks a bit differently, right? And the last thing we want to do is draw a circle at those coordinates. So circle x, y, 100. If I run that, whoops. Huh. That's weird. Okay, I'm just going to set x and y equal to each 100. I'm not quite sure why that didn't work, but we will leave that aside. My apologies for that. What have I done? Ah, I've missed my globals. Never code in a hurry, kids. There we go. Okay, I'm again going to just quickly switch us over to the sketch. And I am, again, just going to hide my face. Okay, so in here, if I press any key that isn't one of the arrow keys, nothing happens. But when I start pressing the arrow keys, I forgot a background statement. Oh well. When I press the arrow keys, the ball starts to move around. So one thing that you might be interested in trying to do is make it so that if I'm pressing two keys, so if I was pressing, for example, left and up, it moves on a diagonal. That's actually a little bit tricky to do, so if you can figure that out, kudos to you. But this is an example of how you can move the ball using just the kind of key pressed and key coded variables, which are the... I say they're simplest. I don't mean that in a derogatory sense. They are the simplest ones in that they have the least kind of complexity to them. But you can see also that they don't necessarily do everything you would want them to do. So right now I'm pressing both up and left, and you see it's just moving in one of those directions. So if you want to do stuff like having a character move in diagonal directions, you need something a little bit more complicated than this. Okay, I'm going to switch us back to our presentation because we are now getting into exercises. So the idea of these exercises is that we would like you guys to group up on Discord with some other students and a mentor, and you're going to try pair programming this. We'll share the answers for these, for how to do these, later on our Google Drive, and we will make sure you all have access to that. But for the moment, Richard will hopefully be on top of telling you all what to do as far as this goes. If he isn't, feel free to shout at him in the general chat. I'm actually just going to pull up the Discord to see how that's going. Thank you also, Richard, in Discord for clarifying the most recent challenge question. I'm also just going to turn off my face here real quick because I'm not very important right now. Um, okay, that's pretty much all we have for you today. Those of you who are still on this stream, please do feel free to go onto Discord. We've got a bunch of mentors on there who are happy to help out with this pair programming. Unfortunately, this is not working quite as well as we'd hoped, so it might end up just being one mentor kind of walking a few of you through it, so that you all can ask questions kind of more individually. But the answers will be shared on Google Drive. Again, any general questions, do feel free to ask those. I am on the Discord. I'll be kind of showing how I would go about doing this. But again, we will post the answers later. So if you're interested, pop over to the Discord and have a look at that. Otherwise, I hope you all have a fantastic weekend. And Jed will be presenting on Monday, as per usual. So he will see you then, and I will talk to you all later. Cheers.